Welcome to today's Leetcode daily challenge problem. So first, let's now read the problem statement and try to understand what it's saying. Then we will think of an approach, the naive as well as the better approach, and we'll implement the better one. So let's see how we are going to solve the problem. Okay. So the problem statement is that we are given the n nodes. It's okay, 5 nodes in this case, and we are given a directed graph and the possible edges and the directed graph and the also the self edges and the parallel edges are also possible. That means that between two nodes there can be a red edge as well as a blue edge going from the node 1 to node 2. There are also blue edge and there is also red edge, and there can also be a self edge, which means a red edge to itself. Okay, and there also can be a loops possible, cycles are also possible. And given we are given two arrays, red edge and the blue edge, where each one of them indicates the edge between the two nodes with the red edge and the blue edge. What we have to return is that we have to return the shortest path of each node from 0 to x, and the condition is that the path should consist of the alternating nodes. That means that the colors should be alternating, not the simple red and blue. There should be alternating, otherwise we will return -1. Okay, store -1 in that place. So that's the problem statement. So let's now take an example. So this is our example, and what we have there. So we are given this. So there are 4 nodes possible: 0 1 2 3 4, and these are our red ones and these are our blue ones. So let's now draw them. Okay, so for 0 to 1 there is a red one, and for from 1 to 2 there's a red one, and from 2 to 3 there's a red one, 1 3 to red one, and for blue one I'm using green. Okay, so from 1 to 2 there is also blue one, and from 2 to 3 there is also blue one, and from 3 to 1 there's a blue one. Okay, so this is our graph. What first we will draw this, and we will represent edge colors as weights while constructing. So red is 1, blue is -1. Okay, and we'll construct it as a weighted one, where weighted directed graph where red is 1 and blue is -1. And how will we approach the problem? So we have to find the shortest path. So first approach that comes in our mind is BFS. Okay, we will do the BFS. Suppose if it's a simple problem, we will do BFS from here, and this and this that we will be able to calculate the path. But this is not a simple problem. We are given a condition that the path color should be alternating. Either it can be red blue. Suppose for a node, up to a node, it can be red blue, or it can be blue red. Got it? That means for a single node there are two types of paths possible that are reaching him. Either the last one could be red and it can be blue, and for its blue the last one should be red, and the last one will be blue and its last one should be red. Okay, and we have to take minimum of them. The shortest one will be our result, and if none of them exist, our result will be -1. So that's the problem. There are two types of paths possible, and we have to take care of both of them. Okay, so how we will take care of both of them? So in this test case, we will be able to observe a special thing, that for 4-1 the red one is obsolete if we are just doing one simple like this, because it's red blue red. But we have to do a circle, a loop one time, and then we will be able to move here, just like red blue, just like red blue red blue and red. So its answer will be 7. Got it? Because we have to travel in the loop one times and then reach here. Because of the red's last one should be blue, only then this is possible. So the shortest path to fourth node is 7, not -1. And how will we able to approach this problem? And the one thing we observed that is that there are two type paths possible. For each of them I will construct a separate array. separate array, distance array, and I will initialize all of them with int max. Int max means it's not visited. Okay, so I will try push it in a queue to run the BFS, and then I will visit its neighbor. And while I am visiting its neighbor, there can be two type of conditions. Its neighbor and the edge can be red, and if the edge is red, we have to check for the last blue edge. We have to check that if 0 is visited by the blue one. Okay, just like here, if we are visiting third's neighbor, just like fourth, since the edge color is red, we have to check for the last blue one, for the blue distance of the 3. That's it. From 2 to 3 we have to check for the blue one, not for the red one. And if it's red, and if it's blue, we have to check for the red one, for its red distance from the 0. From 0 its red distance, and from 0 we will check its blue distance. So blue distance of 3 plus 1 will give us red distance of 4, and red distance of 3 will be blue distance of 2 plus 1, and blue distance of 3 will be red distance of 2 plus 1. You got it? Because path is like this, red to blue, so its red distance plus 1 will give us its blue distance. And if it is blue, if this edge is blue, the red distance of previous plus 1 will give us the blue distance of the current one. And if the edge is red, the blue distance of the last node plus 1, the blue distance of the parent node plus 1 will give us the red distance of the child node. Got it? So that's what we have to do to consider both of these cases. We will maintain a queue. In queue we will push the node, and that every node we will visit its neighbor, and while we are visiting its neighbor, we are going to check these two conditions using the help of two arrays. So this is our problem, and we will take the minimum of them and add the result. If it exists, we will take that, otherwise we will return it as -1. So let's see its time complexity. The time complexity of this approach will be -1 only, plus big of n only. Got it? Because we are traversing for each node and visiting its neighbor only. Got it? A brute force would have taken an n square, because for at each we would have to travel the graph every time. But using the two extra arrays, we are going to solve this problem. So now let's code it, and you will be able to understand it in a better way. So let's construct a graph. Okay, no. Add a list for a graph where where 1 represents the red edge, and -1 represents the blue edge. Okay, so now let's maintain a queue, and let's first take two distance arrays. For a red distance, initialize with infinity, and a blue distance one, and initialize it with also infinity, where infinity is 1e7. Got it? And the blue distance 0 will be 0 because there are no edge here. From 0 to 0 there is no edge, either red or blue, none of them was possible. Let's make a queue, and in queue we will push the 0th node, and let's now start the BFS. Let's now do the BFS. Let's visit all its neighbors. And its neighbor's node is at it.first and its color is it.second. Okay, so if assume that the current edge is it's red, that is 1, and if it's 1, then we would have to take it's the red distance 1, and from the blue distance parent, blue distance current plus 1 is greater than the red distance of the child, only then we will relax it. Got it? And we will push it in the queue. Similarly, if color is blue and red distance of the parent plus 1 is okay, sorry, smaller, and only if it's lesser, then we will do this. So this is giving me a the extra fill. I think we can also write the stand here because we are imagining the colors as paths, weights. So okay, so this is our BFS, and let's now construct our result array. Okay, okay, then our result will be -1, else result I should be minimum. Okay, so this is the problem. Now let's try to return this. Oh, as I see, I did a mistake here. I have to do this and not this. Let's discuss its time complexity. Okay, it's not working for the second one. It's giving me, oh, I did a mistake here, little bug from my side, I'm sorry. So let's not again try to run it. Okay, so let's now working fine. So let's discuss its time complexity. The time complexity of this problem is big O of n. The space complexity is also big O of n. You can think, because there are n nodes and we are visiting each node at max 2 times, and even if it's n cube power 4 or n cube, that's fine also because there are only 100 nodes possible. So let's now try to submit this. Okay, it's working fine. So this is today lead code daily challenge.